Welcome back to AWS Well-Architected Solutions on Twitch. I'm Julio, part of the AWS Technical Evangelism team, and we are here talking about best practices, solutions, small little tricks, and everything to help you be successful with AWS services and tools. So the whole point of this is talk about the well-architected framework. And the well-architected framework covers these 5 areas, as we call pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. In each of our episodes, we're going to focus on one specific part of the framework. And for that, let's take a look at the framework white paper and where we are in this quest. So we're talking about the reliability pillar in the last episodes. And here in the end of the well-architected framework white paper, you can find some very important resources, the questions, the best practices, and some sample answers. And we've been working in RHEL 3 these past episodes. How does your system adapt to changes in demand? And although this is a very simple question, the answer may be very elaborate, as we've been seeing. And I'm going to show you more resources about it today. But most crucially, we've been doing these 2 things: scaling the workload automatically. So for each type of workload, we are seeing how it can scale without you having to provision and wake up at night and things like this, and how to test it. What tools can we use to load test this app and make sure that it matches our requirements? And since the beginning of this series, we've been talking about doing everything as code and automating all operations with scripts and templates and several forms of code to help you manage what would be a great mess otherwise. So let's see, all the code is here on this repo. So if you're not been following along, check out this FermanJ sitting ducks is the repo for our sample code today. This is very, very simple. It's just a set of YAML templates for CloudFormation and shell scripts to execute them without having to know much about AWS CLI and things like this. And each of those build upon each other, so you can mix and match and play with the kind of component that you feel that's more adequate to your architecture. And let me show you the basics here. On my IDE, I have this project already cloned, and in the artifacts template here, it's just a S3 bucket. And this S3 bucket will host our code, our reports, and everything else we'd like to store is going to be here. Versions for our app, and it's just this generic bucket to create everything. But most importantly, we see this parameter called gallery ID. And this is just a naming standard, and it could be named anything. In practice, most people call this an environment. I'm not calling this an environment, just not to clash with other things that are named environments. So I created this gallery concept, and I'm putting under it any kind of alias. So this is the way we can reference things from one template to another within CloudFormation. I'm exporting this under a name that will be the gallery ID or the environment ID that I'm passing as parameter. It could be any string like deventest, and the bucket name. So I've created this many times in the past episodes. Take a look at that if you'd like. But when we create one of those, you're going to see here in this artifacts stack, I have as a parameter the name of my environment, as I'm calling gallery here, It's dev env170805, and the resources that it created a bucket with this name because it was declared in my CloudFormation template. And in our outputs, I have this key output with this value, the exact name of the bucket I created, and the actual export name. And this is very important because using this name, this export name, any other template in my account can import this reference. And although this is just a simple S3 bucket, we are doing the same thing for VPCs, for any other resource that we'd like to share. So take a look here at the base AJ VPC. We have private tables, subnets, the ID of my virtual private cloud, and everything I want to expose to other stacks. You see that they are in the same environment, and I just followed this naming standard here to make it easy to find in other stacks. And again, this is not something specific to CloudFormation. This is just my naming standard. I'm calling things name of the environment, colon VPC ID, and this is how I call things. And if you want to call them differently, it's okay. I just highly recommend you have a sound naming standard. Makes things so much easier. And in the first episode, we watched how to create instances within this CloudFormation template. We did it using Beanstalk. And if you'd like to check that out, we have the Beanstalk templates here. So in the Beanstalk templates, in the Flask template, you're going to find the YAML resources for the whole app and how to deploy this in Elastic Beanstalk using Amazon Linux, using your preferred instance type, and so on and so forth. Just remember to deploy the app and the environments. So this is what create the environments for you. And here you can see we have an import value. It's the other side of that output export. So this import and export of values in CloudFormation is called cross-stack references. Take a look, it's a very important resource and one that lets you divide your CloudFormation code like this. And we've done it for instances, we've done it for serverless functions, and we've done it for containers. So if you don't care about the EC2 instances and you just need to run containers, you can do this very easily with ECS, and you can use either ECS with EC2 or ECS with Fargate. I highly recommend you taking a look at Fargate if you can, because in Fargate you can only say the CPU and memory that you like your container to execute, and you don't need to manage an underlying fleet of EC2 instances. So that helps quite a bunch. And you can see the same idea here of importing the values from the subnets and other references that were exported from the other stacks. Okay? And those are behind the load balancer and so on and so forth. But we can do better. In this episode, we're going to talk about databases mostly. And to access databases and to execute our code, we don't even need containers. We can go totally serverless. And that's the goal of this serverless YAML template. So we're going to go back and improve the serverless templates a little bit and add databases behind it so we can shoot against our APIs and see how they behave when there is a backend database, because up to now, all we did was very simple compute. We did the Fibonacci sequences for a compute algorithm, but that's not too realistic. So we're going to add a database and move one step closer to a more realistic app. And again, we are going very step by step in this series. If you don't understand, please take a look at the previous episodes, and we've done all those templates step by step, and we're going to keep going like this so that it is beginner friendly and everybody has a chance to grasp what's going on, but we're not staying shallow. In each episode we add a few inches deeper in our dive towards well-architected apps. So let's, to add the database here, first we have to choose between relational databases and non-relational databases. So what kind of database you guys want to see? It's a bit hard at this point because we don't have many requirements yet, so I've just decided to create one of each, and let's see how it goes. So let's start with relational databases on Amazon RDS, our relational database system. So to define an RDS database, again using CloudFormation, we have to define a few things, and the goal, our end game here, is to reach an AWS RDS instance. But as you know, RDS instances and their configuration depends a bit on the engine. And on RDS, you can run MySQL, Oracle, Postgres, MariaDB, SQL Server, or Amazon's engine Aurora. And I highly recommend you take a careful look at Aurora because it solves a lot of the scalability problems of MySQL. So what I mean is, in standard MySQL, it is much harder to take care of synchronization, replication of data, backups. For example, if you set up Moody AZ, you would have 2 instances of an Aurora replication of MySQL replication. With Aurora, automatically you got 3 replicas per region, so it's 6 per region, 2 per AZ, minimum 3, so it would be 6 per region, and it's unbelievably fast. So highly take a look at it, highly recommend you take a look at it. I may got the math a bit wrong there, sorry if I did, but the whole idea is we are using Aurora for this for these tests. And at a minimum, we need a cluster, we need the instance class, and a subnet group. So let's take a look at those resources. First, as a parameter, the gallery ID, same concept, just a name of an environment. The instance class that we would like, I'm using R3 largest by default here, but we can set this to any instance class we want. Our security group, just so we can connect from anywhere I'm opening. Even you guys at home can connect to this instance that we are using today. Not many surprises here. The subnet group is going to tell RDS in which subnets do I want to spin my database. So I'm taking 2 subnets from the base AJ VPC template. And for Aurora, we need cluster-wide settings. So our username and password, again, you can pass this as references or use AWS Secrets Manager or Parameter Store. We're going to see some much better ways of handling passwords. Don't do this at home, but today is about scalability, not security, so we can forgive this a little bit, at least until we go back to Parameter Store and better ways to use passwords. And the DB subnet group name is going to be a reference to this DB's subnet group. So that was created just before. And this is pretty much all we need to create this database instance. And to access it on our serverless application, we have this serverless function defined here. It's called put random on relational database function. So this is the function I created to insert a random number into a relational database table. So it's still pretty simple, not many records and joins and something too fancy. Let's take a look at this put random RDB function. So here it is at my source target. Here's my app, the lambdas.py, and this is the function, right? It's very simple, can fit on the screen here. So I'm going to define this API gateway object. This is just what I use to send responses, and this is just writing my response to the response object. If we take a look at the API gateway API, here, this is something that we did in a previous episode. I'm just creating this interface that I can send data to either API gateway or Flask, depending if I'm running this code behind API gateway or behind Flask, because I can run the same code either way. So this is very simply that. Let me get back to the file, to the lambda, and create a random integer. Please don't judge my Python. Get the environment variable for the DB host. And this is interesting here because if you think about how it works in CloudFormation, the function is created by one stack and database is created by this other stack. But no problem. As we saw, I'm getting the endpoint address attribute of the DB primary instance and exporting as my RDB endpoint address. And on my serverless YAML template, I have this environment variable defined for our function. It's going to import exactly that reference. So this is how I can create the database on one template and import it on another. And that's the same logic for all the cross-stack references. And this is here on in our function, I got the database address. I hard-coded, the credentials here, but we could follow the same process for the credentials, or even do better with parameter stores and secret stores, as we're going to see in upcoming episodes. And create a cursor from the connection, create the database if it does not exist, create the table if it does not exist. And again, I know there are some database frameworks that does this for you. I'm going with the most vanilla SQL I can think of and insert the value into the table and commit the transaction, close the cursors, and that's done. And this is what we have for RDS. This is what we have for a relational database access using Python and running behind this resource name. And I'm just exposing it as a get. I know I could use it the put here. I'm just putting it behind a get and making things a bit simpler to test, but do as you please with your APIs. And I hope that's pretty clear by now. And if you have any questions or anything you'd like to see, please feel free to comment on the Twitch chat, and I would be happy to address that. Yes, I'm pretty aware this is not ideal in security terms. We're going to harden it a lot in security episodes. Let's take a look at how it does scale. And most importantly, let's see how it does not scale when it's the case. And well, this is how we set up our relational database. let's see how the non-relational database of things is, because there is an issue here when we think about scalability. When this gets more and more load, we're going to see that this property, this database, what defines our capacity in our relational database here, it's essentially this database instance class. We could do many things here. We could separate our reads and scale, auto scale read replicas, for example. That's something that Aurora can do. But when it comes to writes, it gets a bit more difficult. We could use multi-master architectures or improve the sharding and many other techniques here, but it starts to get complicated. So in many cases, what people do in these situations is use a non-relational database. And I'm not here to advocate that one is better or the other, just showing you how to do both things with code and automatically with CloudFormation, and how to test both things and help you achieve whatever way you think it's best for you, and most importantly, test both ways so you can find this out. And on our DynamoDB template, here I am doing a very similar thing, creating a database table to store random values, but I can be a bit more open with DynamoDB in terms of scalability. I can reach further, and let's see why that is. Because in our DynamoDB table, we have not a fixed instance class, but read and write capacity units. So this will tell DynamoDB how much writes per second I'm able to do and how much reads per second I'm able to do. And it would be fixed if it was just this, but we have a few other improvements here in this CloudFormation template. Here is just the Dynamodb Vpc endpoint, so we can access this DynamoDB table from within our VPC if we want to. And now the scaling part is pretty important, because in this scaling we use application auto scaling. In our last episode, we showed how to use application auto scaling for containers, and now we're using the same idea for databases, so for DynamoDB. Let's take a look at our rand table write scaling policy, and this is the policy that tells AWS how my provisioned capacity for this table should be adjusted. I'm going to create a policy that will track target tracking. So target tracking means that I'm not going to create the alarms and tell AWS explicitly how to scale up and down, but I'll tell AWS to move towards this target, to follow this target of 70%. So if my utilization of write capacity is getting close to 70%, DynamoDB is going to scale up automatically for me, and it will wait for a while before scaling back and forth. So here's this cooldown is a bit too long for our tests. I will move this to 30, is probably a bit better. And we need to actually test this, and it's the same thinking we did for the ECS and containers episode. If this target value is too low, if you set it to 40 or 50%, for example, you will scale more aggressively. You will keep a lower target, and you may incur in more costs, but you have more room to work with if your spike of demand is too high. If you set this target value too high, you may not scale until it's too late. You may end up only scaling when you're, for example, at 90% utilization, but you will be more conservative in terms of costs. So this is a trade-off that requires a lot more testing that we are able to do in this session, but it is important to think of these values. And this is for write capacity, just for writes. We're only doing writes today, but we could do the same thing for reads. On the read side of the story, it's exactly the same thing, but the dimension we're going to monitor against is read capacity and the rand read capacity, scalable target, and just set the same things but for reads. And this way you can tell DynamoDB to adjust its own provisioning when you have more reads or more writes. And that's what makes target scaling so much simpler than having to create alarm per alarm and move everything yourself. And in the same way we did for relational databases, we export our random table name, the actual DynamoDB table here as a DDB rand table. And in our serverless YAML, in the environment variables for our put random on DynamoDB function, we add the environment variable with the reference to exactly that table. So when we create this, and I have created it beforehand, so we don't have to wait for everything to come up every time and save us a little bit of time. And I just did this today, and I did it several times with you on stream. Check out the script, just run the script, and it would create exactly the same stacks. And here on the serverless stack, let's double check the resources that were created. Something happened here. Let me refresh the console. I think I missed authentication. Okay, so for example, on our DynamoDB function, on the Lambda console, we get this hard links on the console. We can see it's got access to DynamoDB, to CloudWatch by the Lambda role that was created there. And on the configuration right here, we see the random table name mapped to exactly the correct variable value that was created by CloudFormation. And on the code, let's take a look at the DynamoDB version of the same code here in the lambdas.py. So the DynamoDB version, it's a bit shorter because all it needs is the table name, and it will get us the table name, create an item with just this integer, and put item to this table. So I don't need to create database, create table, and so on and so forth, but it's pretty much the same thing, right? The operation is a bit different. In DynamoDB, you don't have a query language as you have in SQL. Here in SQL, you can just issue a SQL statement. And in DynamoDB, the equivalent thing would be a put item API call to insert this into Dynamo. And let's see how those things behave. And to do that, we've been using Gatling. And Gatling is a load generator. We have the load testing defined in source test sdux load testing db. So this is our test case. It's still quite simple. We add the requests for each of our endpoints. I created one for the DynamoDB, one for the relational database, and for each of those, we're going to ramp up some users. And I changed a bit the logic here from the other episodes. In the other episodes, we did this static ramp up of users. Now we're going to be a bit more fancy and ramp up users per second. So we're going to start with one user per second and go up to any amount of users that we pass as a parameter to our test case. And again, this is a great thing of having simulations as code, because we can interact with any kind of parameter passing that we'd like, or repeats, or fors, or it's much easier to handle things in code than having to go through clunky UIs and these other test generators. And that's why we're using Gatling for this series. But in future episodes, we played one time with JMeter. We are going to add others and play with Locust and anything you guys may be interested in. There is bees with machine guns, there is Grinder, there is many other load generators we can use here. Let me know what you guys would like to test. If you'd like to see message queues, other types of databases, caches, Elasticsearch, it's our pleasure. We're bringing here everything you guys are interested, and well, I'd love to hear your opinions. But for today, we're shooting against relational database and non-relational database and seeing what happens. So to not do this from my own remote machine, I have a separate machine set up, and we can do this from SSH, because here I have a quite more capable machine. I have a provisioned a C5 instance, and we can see with, I like this glances tool, not finding it on the history. Glances is this monitor just to make sure we don't run out of resources, but we should be good with this 72 cores, 140 gigs of CPU. This should be letting us generate a lot of load. And going to our application there, here's how we pass parameters. So I will copy this line, this Java opts. I'm passing how many users I want. 4 is probably a bit too little. Let's do like 10 and ramp up for 5 minutes and see what happens, or 10 minutes and see what happens. And the run description is just DB, and let's just double check the endpoint that we got from CloudFormation here in the output of our serverless DB. So this is our URL, UBC EA, and it's exactly this. So if you'd like, you can shoot against the same API. And this is the test that we're going to run just now. So set this variable on the remote machine and run the test case. And just pass the Gatling test only, pass the name of the test that you want, and SBT, the scalability tool, that's what Gatling is built upon, is going to run the code for us, not much more to worry there. So tests are running. I see 200 OKs coming up. So we just need to wait for this test execution. And not to make you guys wait for this 10 minutes that I set up here, I got some executions of that already. And the way we reach it is just load the Gatling's directory. So I had it here in that machine. It's running SSH tunnel. So here's the output directories for my load testing. Here's the new one that it's running right now. Here's the one I ran previously. And if we take a look at it, it's not as exciting as you probably would expect, because we don't have a lot of data and load. And this is again just our first scenario with databases, but we can see some very interesting details here. The first one is that if you compare the database random from DynamoDB and from the relational database, except for this difference in network errors, if we check the latencies, it's not actually as different as you would expect, because, wow, DynamoDB is this super fast database, ultra low latency, but our relational database is also very over provisioned. We are running with an R3 large, so we're probably not reaching the limits of both, at least in this first case. We can scale up, and the whole idea of load testing is checking out how the application scales, what are the utilization thresholds, what are the saturation limits, and we're going to keep pushing these resources until we reach that point. So along the simulation, we started with 0 users per sec, and we are running up to 30 here in this case. I just added a bit more so we can see how our response percentiles behave over time. And when we have some side effects such as queuing of requests, we're going to certainly see this kind of spikes here. So this is how we can understand this question of how do our application behaves as the load increases. And well, in our case, for this specific load, we did pretty well. It's very hard not to see any errors, just important to understand why they happen, what are those 504s, why this queued up for so long. It may be an issue for your app, maybe something simple, and client side even. So take a look. It's very important to get to CloudWatch logs and see what's here. If you don't know what I'm talking about, we did it several times in previous episodes. I mean, just go to monitoring and CloudWatch logs, and you can see exactly what's going on in this function. So here, I don't have any data for these requests. We probably should use a log analyzer or find a better tool than just going through the console and automate it a little bit. But every log file and every request is here. So here's how you can understand what's going on. How many invocations, all the CloudWatch details, everything is here, not only the logs. So that's the how you can find what's going on. And the case here is that the network latency, just getting to the server and invoking an API, has got so much more work to do than the database work that we're doing, just inserting a simple integer, that in this specific case, the database work is not, it's dominated by the latency of just getting the HTTP request through. And we know that's not always the case, and this is the goal in this series, trying to find out the corner cases and the situations in which we have a different scenario, right? Let's see if there is anything else that I'd like to share with you guys. Let's see how our simulation is still going on here. Please take this code, give it a spin, and see if your numbers differ, how far can you push this, and I would be happy to add more information and cases here. What I'm doing today, just showing you guys this very important part of scaling with databases. So in our Dynamodb table, by now we can probably see what's going on. So on Dynamodb, let's go directly to the Dynamodb console and see how that table is doing, because we can probably see the auto scaling going on there by now. So on Dynamodb, on the tables, this is the only table I have in this region, and on metrics we can see our write capacity. It has gone up, right? We are on 15 write capacities from our starting point of just 5, because it grew according to our capacity requests. And here, if you see the capacity logic, it's exactly as described in our CloudFormation template. So this is how you can set a serverless backend with a serverless database. And that's pretty powerful, because we don't need to care about scaling the functions, because the functions are going to scale automatically for you up to the concurrency limit defined for the function. What? Let me say that again. Here on your each lambda function, you can set the concurrency limit, right? By default, it's unreserved, and it's up to 1,000 executions. So if you have 1 user, 10 users, 100 users in parallel, Lambda will invoke this many executions for you. On Dynamodb, on the other hand, if we have more and more capacity, when we reach about 70%, it's going to scale up in capacity units up to 100 units in my defined case. So this is how we can make sure that no matter how much pressure we put in this load tests, our Dynamodb table will keep up. While I'm certain that at some point, we didn't reach that yet, but at some point, this database table that we added on RDS, let's take a look there as well on the RDS console and see how this table is doing. And here on DB instances, here's our Aurora instance, and it's pretty easy. By now, we don't have many users yet. This is a R3 large database, so it should handle a bit of load without too much trouble. But at one point, when it reaches 100% or 90% CPU utilization, we're going to have a problem. And again, let's take a look at how do we know it's going to be a problem. Well, take the resource constraint here, our DB instance class in the RDS instance template, the CloudFormation definition for this type, and in database instance class, you can see that if you change this instance class, you will have some interruptions on your code, while if you change the provisioning of a Dynamodb table, it doesn't have any impact on your running code. So that's how you can scale without being worried to yeah, that's it, Stanky. About the load testing behavior, we are scaling not users, but users per second. So we changed the definition here. So it's no longer ramp users, but ramp users per second. So the amount of users per second is what's actually increasing. And that's probably what we want to test anyway, because we want to see the load going up and not just how many users are we able to achieve. And well, let's see, in our sniper machine, things are still pretty easy. Our testing is done. I managed to talk with you for 10 minutes while this goes on. And it's 285 on the ending of our directory name. So that's this one. And here it is our results. We got 21K requests fired. And again, if we check the RDB case, we got 2 errors here, probably due to queuing. We got definitely, it's very hard to get to 0, but very important to look out and hunt those in the logs and see what's going on here and try to prevent those errors. But this error rate is perfectly common in load testing, at least from what I see. And here you see again the latencies are still not very different. So at the 99th percentile, perhaps a bit of difference, but I'm gonna keep pushing this with more and more load until we reach the point where DynamoDB and RDB starts to separate, because the main difference here is relational databases are trees. DynamoDB is a hash map, has conceptual data structure, so this should be much more scalable. And as we have more and more data with more and more users, that's certainly going to become more apparent. But again, take a look at the sitting ducks artifacts. This is the templates that we use it today. The Beanstalk and the ECS templates were covered in the past. Today we are using the serverless architecture, so the serverless resources are here. Be sure you understand how we pass variables and cross-stack references, so we are able to insert in one database or another inside our function. The code of the functions is this lambdas.py. So because this is sducks.lambdas.put run RDB, this is on source main Python sducks and lambdas.py. And here's the code for both the DynamoDB and the MySQL version of things. And an extra is the shell scripts, and everything here is very easy to create. Just run this shell script and it should run the AWS CloudFormation deploy to deploy this code, and you would be able to run all those yourself. And again, this is just a very simple exercise showing you how to declare databases with code, how to stimulate them with load tests, and hopefully understand how your APIs scale as your users grow, right? Let's take a look at if there is anything else in our Gatling report. This is the new one. So we ramped from 0 to about 30 users per sec. Our response time distribution was around the 120 milliseconds, so everything quite compressed here, not many outliers, which is great. Some queuing probably happening here, better take a look. And we can see that our application is ramping up pretty nicely. And I hope you enjoyed today's episode, and I would be happy to take questions. And if you'd like to see anything at all on twitter.com/FurmanJ, like this. I would be very glad to continue this conversation with you. Let me know what kind of app you would like to test, what kind of app are you building, and how can we help you be successful with that. All right? Thank you, my friend developers. See you on the next episode. Bye bye.